Uh, in this third video, I will talk about Borel set of A. And first of all, I want to give you a motivation of the Borel set of A. So in the previous two videos, I talk about sigma algebra in the first video and probability measure in the second video, and I also provided some example. With that example is start from a random experiment flipping a coin for one time, and in that experiment, we get the sample set omega, which is equal to h and t, and so it is a kind of discrete set. We can see exactly what the element of omega, what is the number of the element of omega. So another question come up: if omega is a continuous set, omega equal to r, for example, so what is the sigma algebra that we can uh, find from this omega? I mean that what is the sigma algebra on r? So if I ask you about what is the power set of omega, because in the previous two videos I provided some example that I used power set as a sigma algebra, and so can we find the power set of r or power set of omega in the case that omega equal to r? So we don't know about it because uh, we cannot write down the power set because r it is, I mean, there are infinitely many elements of r. So instead of working on the whole power set, so in this case I start from a subset of the power set that I denoted by A, and A it is the set of any open set in R. It means that A contains all open set in R. And my question is, A is a sigma algebra or not? So uh, to see if A is a sigma algebra or not, let me go back a little bit to the definition 1.1 that talk about the concept of sigma algebra, that talk about the definition of sigma algebra here. So definition 1.1 said that let omega be a non-empty set. It means that we have to make sure that our omega, our sample set, an is not an empty set, and a sigma field F or a sigma algebra F on omega is a family of subset of omega such that 1. The empty set belong to F. Second, if A belong to F, then the complement of A, which is equal to omega minus A, also belong to F. And the third is about the union of the sequence of set in F had to be belong to F also. So we will use this definition to check if our set A is a sigma algebra or not. So, okay. The answer is no. Why? So let's go to the first condition about the empty set. We know that the empty set is open and closed, and A it is the set that contains any open set in R. So empty set it is an element of A. So the first condition of sigma algebra is satisfied. But for the second condition about the complement, if if we have B belong to A, it means that B is an open set in R or open interval in R. Let's say B equal to AB, that A less than B and AB are rational number. So then if we find the complement of B, it is equal to A minus B, and it's equal to this set. And this set is not open set in A, or it's not open interval in A. So in this case, the complement of B is not belong to A. So if complement of B is not belong to A, it means that A is not a sigma algebra. So how can we get the sigma algebra on A? Another statement. Let F be the smallest sigma algebra that contains the set A. We call F is a Borel set of A and is denoted by BA. So totally, in this case, I mean that if we have the set A, which is the set that contains all open set in A, so we put some element to make A is the sigma algebra. So that sigma algebra, that smallest sigma algebra that generate by A, it is called Borel set of A. And Borel set of A, it is contain every subset of A. And the notation of Borel set of A is B of A. So Borel set, it is an important concept. I talk about Borel set in this video because the next video I will use it to talk about random variable. So that's why this one I want you to see what is exactly the Borel set of A. Actually, you can like construct a Borel set of an interval of A, not necessary A, and we put some element, some, interval of A to make it a sigma algebra. So it will be the Borel set of the set that you want to, that you want to get the sigma algebra, the Borel set, something like that. And we also have a small theorem that the theorem states that the Borel sigma algebra of A or Borel set of A is generated by interval of the form minus infinity to A, where A is a rational number. And I won't prove this theorem, but if you want to see the proof of this theorem, you can open the textbook. The name of the textbook is Probability Essential, and I don't remember the name of the author. Maybe Ginger Code, and yes, on page 8. So this is a theorem of the Borel set. Okay, thank you and see you in the next video.